Okay, so this is a video for students who are going to approach doing 4.4 in the engineering course, and you haven't yet done it. We're going to be doing differentiation and integration, which is, an IB, SL, and HL uh, mathematical technique that looks at rates of change. It's quite a challenging concept, and so we'll start by going back a step to GCSE, and this is from something from GCSE level 6 on basic gradients. You may remember it from GCSE. You may have forgotten how to do gradients, but we've certainly worked with gradients all the way through high school. And so complete these tasks, and that will give you a solid basis then to move on to that harder concept of differentiation and integration that we need to do for 4.4. So in this question, you may know how to do it straight away. There are some formulas for gradients. You may remember that to define a gradient, it is the rise divided by the run. You can also do the online lesson here on my iMaths, but I thought you might want this video too, just to talk you through these questions. And this is also defined if you've got two coordinates, you can have x, you can actually have y1 minus y2 over x1 minus x2, where if you've got two coordinates, the first coordinate A would be considered as x1, y1, and B would be x2, y2. So that's a way of doing a mathematical formula for gradient, y1 minus y2 over x1 minus x2. That's in the formula booklet for things like IB diploma courses. So that's how you can do it. So you can do it straight from the formula there, or you can think about this if you're not so confident doing that just yet. So there's the formula with these coordinates A and B. If you're not quite there yet, then maybe have a think about drawing a pair of axes. A is at 5, 1, 1, 2, 3, 4, 5, 1. Remember, it's along the corridor up the stairs, so along the x-axis, then up the y-axis, 1, 2, 3, 4, 5. Remember, when you're counting, make sure you're counting from 0, 0, 1, 2, 3, 4, 5, and 1. And 9, that's 6, 7, 8, 9, 1, 2, 3 would be there. And you can get a visual representation of what that gradient will look like. There it is. It's the steepness of that line, 2 divided by 4, 2 over 4, or 1/2. Okay, so that's how we could do it. You can see here that if I run along and rise up, there's 2 squares there and 4 squares there. So my gradient between A and B, that's my A, that's my B, would be the rise over the run simplified to 1/2. Obviously, you've got to remember there how to simplify fractions as well. Okay, you could give that as 0.5 as a decimal if you wanted to too. These are a bit more difficult, but you could just still draw them if you wanted to. 4, -2, and 6, -1. So 4, -2, 6, -1. What would they look like? Yeah, similar thing. Draw a pair of axes. Draw a pair of axes. Okay, drawing here. Pair of axes, x and y. C is at 4, -2. So 4, -2. There's C. D is at 6, -1. 1, 2, 3, 4, 5, 6, -1. And the gradient of the line between them. The gradient of the line between them, 4, -2, and 6, -1, has a rise of 1 and a run of 2. So again, the gradient here will be the same as above, 1/2, 1 over 2. Now, of course, you need to work towards, and certainly with the work we'll be doing in engineering, you definitely need to be able to use formulas and be able to use the abstractions without necessarily drawing everything out. So let's do this one, x, y, without using we're just going to use the formula now. So x is at -2, -6, and y is at 2, -2. So we're going to use this formula here, my gradient. We usually call the gradient m. If you remember from y equals mx plus c from GCSE, we usually call the gradient m. So what we're going to do is use that formula. M is y1 minus y2, the difference in the y values divided by the difference in the x values. And as long as we're consistent through that, we can just choose one of these to be the y1, x1, y1, and the other one to be the x2, y2. And so the gradient will be, I'll choose this one as x1, y1. Let's mark it up. That's going to be x1, y1. And this one will be x2, y2. So then I just substitute the numbers in. So y1, -6, minus y2, -2. And then x1, -2, minus x2, 2. So y1 minus y2, difference in the y values over the difference in the x values. Obviously, this is going to really test your understanding of negative numbers, something else at GCSE, which may have been a bit of a challenge, sort of working out what -6 minus -2 actually is. What is -6 minus -2? It's -6, add 2, which is -4. And on the bottom, -2 minus 2 more is also -4. So the gradient there is 1. Again, that working out there might be a little challenging in terms of the negatives, but you can certainly get it done. You're allowed to use a calculator, I suppose, as well, so you can just put these numbers in your calculator and get the right answers for those. That's the first set of questions. Then you're asked about a quadrilateral four-sided shape, A, B, C, D. It's got vertices, that's the corners, and there's the 4 corners. Work out the gradients from A, B. So similar thing, you've got to work out the gradients between those sets of points. And the question then says, is the quadrilateral a parallelogram? And a parallelogram would have sides which are parallel, in other words, the same gradient. So if in this question you get pairs of same gradients, same numerical gradients, then yes, it's a parallelogram. If you can't tell, and if you can tell, but they're not pairs of parallel, and you can work out what shape it is, you can choose the option there. But you've got to do all this working here to find out the gradients and then decide what shape it is. So good luck with that one. Okay, moving down here, this is the second question of the online homework, and nicely they just give you the lines and you've got to work out the gradient, the x-intercept and the y-intercept. So in this case, there's line A. We can just look at it straight away. I can pick 2 points on that line. There we are. Maybe do the lesson just to remind you what these are. Pick 2 coordinates on the line, and that rises 3/1 to the gradient's 3. What's the x-intercept? Where does it cross the x-axis? Crosses the x-axis at the coordinate. I think it doesn't need a coordinate. I should think they just need the value 1. And the y-intercept, that's there, is -3. Features for B. Similarly, you just pick some coordinates on the line B. B runs along 1 but goes down 3, so that's got a gradient of -3. Again, do the lesson to make sure you remember from GCSE what a negative gradient, what's a positive gradient. The x-intercept is 3 and the y-intercept, sorry, that's wrong. The x-intercept is the same as A, it's 1, and the y-intercept is +3. Find the features of the line y minus 3x is 27, again from GCSE, but you may need to do the lesson here. You need to write this in terms of y equals mx plus c. You need to rearrange this equation, and that is rearranged by adding 3x to both sides. Y equals 3x plus 27. So the gradient is a value of 3, and the y-intercept is 27, but it doesn't ask us for that. The y-intercept is 27. Oh, it says, oh, what's the x-intercept? Well, that's where y is 0. So you're solving the equation. Where is the y value 0? You may remember that from GCSE, that you've got an x-axis and a y-axis. On the x-axis, the y-ordinate is 0, and on the y-axis, the x-ordinate is 0. So where is the x-intercept? That's when the y-ordinate is 0. In other words, where 0 equals 3x plus 27. And that's where x is negative, solving that equation, x is -9. So it might be easy to go from here, actually. Look, where the y-ordinate is 0, you got 0 minus 3x is 27, whereas -3x is 27 when x is -9. So there we go. So you'll have different numerical values on your homework, on the kind of homework tasks that I've set for you. But yes, it's going back to the kind of, the the kind of basics of gradient and straight lines. When we move into the harder work on integration and differentiation, we'll be looking at lines which are curved lines with variable gradients. And so really to make sure you kind of really remember and are confident with the concepts of gradients of straight lines and intercepts of axes to start with before we get there would be a really good idea. So good luck with those. You've got the lessons to follow through as well, which will remind you all of these things about y equals mx plus c, gradients, y-intercept, x-intercepts, coordinates, how coordinates work, what an x-ordinate is, or what a y-ordinate is, and all of those things. So good luck today. And I will speak to you next lesson once I've been through some of the other students' work. Good luck with that.